Okay, welcome to a basic weather CPD session. There are lots and lots of webinars out there at the moment, and I hope you find this one useful. As it says on the screen, my name is Rod. I've been teaching weather as part of the Yachtmaster scheme for quite a while now. In fact, I'm counting that in decades rather than years, which is a concern, but also I found that really useful when teaching in the small boat scheme as well. It can feel like a bit of a large and daunting subject, so hopefully this will help to just simplify things and make it easier to teach for you moving forwards. So just to give you a bit of a background from me, I came into the boating world in very small cruisers about the Clyde in the west of Scotland, and though I entered the industry in relatively largish vessels, sail training and occasional races offshore, etc., I have also enjoyed teaching in the small boat schemes as well as a dinghy instructor, a windsurfing instructor, and do the power side also. I also teach in the classroom, which I never thought was going to happen, but it definitely has. So I've embraced that and really enjoy it now, and that's definitely involving weather too, especially on the Yachtmaster scheme, but teaching in the classroom to those who require it. So what we're going to cover today then. Hopefully get through some synoptic charts, temperature effects, so that the fact that temperature drives the whole weather system, but also some more local effects of temperature, a little bit on the land and how it can have an effect, the terminology, some of the jargon and the scales that we have to kind of make sure we're all singing from the same hymn sheet, and passage planning, because of everybody who goes onto the water inevitably goes on a passage, whether that's on a stand-up paddleboard or on a super yacht, it doesn't really matter. Okay, so let's start then with the synoptic charts. So sounds like big boat stuff, but really you want to be looking at a synoptic chart regardless of what boat you're going out on, or as I said, whether it's a stand-up paddleboard or not. It's just nice to know what the big picture is, what we are expecting to happen over the course of whether that be a few hours or a day or maybe even a week. So looking at the synoptic chart is definitely really important to set the scene for you. It can be a bit overtaught in my experience, especially on instructor courses. So I've seen people coming along to instructor courses and crack straight in there with navigable semicircles of hurricanes, when actually we don't know if our students understand the basics. So I like to start with this kind of drawing, which is really simple, symmetrical low pressure system, very circular, very straightforward, and a very simple picture of some land. In this case, you've hopefully worked out from my art skills that this is the United Kingdom, and apologies to my home nation friends who maybe aren't very well represented in Wales. I think is probably the worst off on my drawing, but you get the picture. That's the UK, that's the low pressure system. The more simple it is, the better and less cluttered for our students. Okay, so I'm going to get you to engage your brains with a question straight off the bat here. So in the Northern Hemisphere, where I am right now, looking at a low pressure system in particular, what direction do you think the wind travels? I'll give you a few seconds for that. Now, hopefully you're scratching your head a little bit and going, oh, is there more than one answer? The answer is all of the above. So we do expect the wind to be traveling anti-clockwise around a low pressure system, definitely towards the centre, bending in the way, because nature abhors a vacuum, and we do refer to them as cyclonic. So a little bit of a trick question in there, but just getting our brains engaged. But well done, everybody. You're all correct, regardless of which answer you chose to go for there. If we've got low pressure systems, we obviously have to talk about high pressure systems too. So looking at the low pressure system, generally the first thing that people ask is, what direction is the wind? And as we all correctly answered, if we watch the animation, we can see that the wind is traveling in an anti-clockwise direction in the low. And then if we look at a high pressure system, we expect the opposite to happen. Great. So building on that then, if we can look at just the low pressure system for the time being, and if we can take that to the next level, once we've talked about the wind travelling anti-clockwise and we've got a rough idea of the wind direction, we can then mention a little bit about the spacings of the isobars, and the closer they are together, the stronger the winds would expect. Building further, I would usually then move to the fronts and how that there's different air masses and that they have quite a significant role to play in what we are going to experience. So if we just describe that red or circular front, semicircular front, that's describing and displaying where the warm sector is, or the warm front is, and behind that will be a warm mass of air. Beyond that, you've got my lovely drawings of the blue triangles representing the cold front, and behind that is where the cold, more dense mass of air, which is usually travelling more quickly and pushing the warm air up and out of the way. So it's also useful to know at this stage that generally speaking, we expect the low pressure systems to track across the Atlantic and to hit the west coast of the United Kingdom, moving in generally an east or northeasterly direction. Okay, so let's now ramp it up to the giddy heights of the clouds. And unfortunately, we don't live in a two-dimensional world, so I've had to kind of mess with our brains a little bit, and now we're not looking as a plan view from on top. We are now looking more on a horizontal plane. So see if we can get our heads around this. Is a great picture. I've never found one that's been better at showing what we need to kind of get into here, and it's straight out of one of the RYA books. And in particular, I use them as ebooks, which I'm sure you all do as well. So looking at the different clouds then, so all of our weather really happens under the tropopause, so the troposphere, and that's quite a large area, and that's where our clouds all kind of hang about, if you like. The really high clouds, the cirrus clouds, are the ones we expect to see at the start of our low pressure system. So if you like, how I think of it is, if I see those kind of high whisked out clouds, I expect there's a low pressure system in the post that's probably coming to me either in the next so many hours or the coming days. So you might remember or have heard a lovely bit of poetry. So mare's tails and mackerel scales causes us to reduce our sails. So those first set of clouds, those high wispy ones that looks like horses' tails, those mare's tails, and then slightly after that, the kind of almost scale-like mackerel skies. That's your cirrus stratus, so that layer of kind of almost bumpy looking clouds. That's the telltale sign that a low pressure system is actually on its way. As it comes across from the from the west to the east, we expect probably to see a lower bank of cloud. We call that altostratus, and it just gets thicker until we end up with what I refer to in Scotland as schmung or drizzle, or just that really wet kind of experience of the nimbostratus, where the visibility is not great because you've just got lots of moisture in the air. So then we move on to the probably more dynamic looking kind of clouds that are stand to great vertical height, and we call those cumulonimbus, and they can tower way up into the top of the tropopause. I've always found that when you start talking about the clouds, the students can glaze over a little bit, and it all becomes a little bit too much. It's literally Latin, I think. Certainly Latin to me when I was first getting taught it. But I've broken it down into two fairly major and simple sections to remember my clouds by, and it certainly doesn't work every time, but it is a good rule of thumb. So if you like, looking at the height of the cloud, we've got cirro or cirrus, referring to high clouds, alto, like an alto saxophone or an alto singer, being lower than that, a little more kind of mid-range. And then if we don't actually have a prefix when describing a cloud, we can generally assume that that's quite a low-level cloud. If we then flip to the actual structure of the cloud itself, we've got cumulus or cumulo, which just means an accumulated puffy kind of cloud, and we also have stratus, which would refer to a layer of cloud. Here's a couple of examples where you can mix those two different sections together. So referring to alto cumulus, so that just means a mid-level, but it's a puffy cloud, or cirrostratus, which is a high-level layer of cloud. So as you can imagine, there'll be many meteorologists that are, pulling their hair out, going, yeah, it's really not maybe as simple as that, but it works for me, and it certainly keeps it nice and simple for our students, so we don't bog them down with the thousands and thousands of different types of cloud that we have out there. Okay, we have another category of cloud, which is nimbus or nimbo, and really for me, that just means expect some rain. So anytime that you see nimbo or nimbus in the name of the cloud, then just be prepared to get wet. So let's head back to the synoptic then, and just remind ourselves where we are with that. We've got our wind direction. We know roughly that the wind strength is down to how close the isobars are together, and we've now got a better idea of what's happening in the sky with regards to cloud and maybe even visibility as we experience the different parts of this low pressure system. So we're going to track this across the screen, this low pressure, almost like it would do in a textbook scenario, and talk about the various different kind of sections that we might experience. So as it moves, we can expect the centre of the low usually to head just across the top of the UK, and probably one of the first things that we're going to experience is southerly winds, and that's fairly common about here. I think you'll all agree. We'll expect the pressure system to be relatively high, and if anything at all with regards to clouds, we might start to see those high-level cirrus clouds that are letting us know that there's a low-pressure system heading our way. If we just move on a little bit further, we'd expect the wind direction to change and probably experience more southwesterlies. We'll also experience the pressure dropping and definitely getting the lower cloud, and possibly even getting a bit wet at this stage. So we're starting to see some fairly fundamental changes, letting us know where we are in the pressure system. A little bit further then, the pressure is likely to kind of steady and stop dropping and just become a bit more constant. The winds bending round more to the west, and the cloud might be starting to see, if not overhead in the distance, a nice big clear bit of sky, but with high towering cumulus clouds that are on the way, if not already here. And then last but not least, before this particular low pressure system heads off, we're likely to be experiencing the northwest westerly winds. Good clear visibility, except for in the any showers that are under the cumulus, and the pressure should now be rising, letting you know that you're passing through and out the back of the low pressure system. I guess what happens next would depend on what is behind that low pressure system. It could be another low pressure system, of course, but it might be a high pressure system. And as we've said, this is a really textbook simplified version. It's likely to be a little bit more complex, but this hopefully gives us a really good understanding. So let's have a look at something that is a bit more real than my perfectly circular textbook pressure system. So if we look at the left-hand side of the screen here, this was something that happened just a few days ago. I took a couple of screen grabs and hopefully that'll help us look at something a bit more real. So you can see the cold front to the north of Scotland there, and in reality that trucks south, depending on you know, how quickly you're watching this. You might even have remembered that there's you know, fairly recently there was a cold front that transferred the weather from being sunbathing weather in the UK to snow in the Highlands of Scotland the next day. So that was this cold front that brought that cold air with it. As we've already discussed, we expect there to be some clouds round about that front. We expect there to be clouds near any front, really, but in particular, you know, the kind of high towering clouds that will bring some quite full-on squally showers. So if you look to the right, you'll see you know, the rain radar picture that describes better the actual cloud formation and where it was raining. And if you look further right again, I've put in a waypoint where I live and where I was sat that day. And if we can just move on to the next slide, we'll see what I was witnessing out the window. So 1 minute it was sunbathing weather, the next minute there was some squally showers came through, and it was definitely not sunbathing weather. So hopefully, you know, that will help put together the cold front. If we can just go back a little bit then, just to have another look back the way at the fronts, and see if we can see that there's also the occluded fronts coming in here. So we haven't really talked about those. I'm just going to put in a nutshell something that stuck with me for quite a long time, is that when the cold air catches up and starts to push the warm air mass up and out the way, we call that the fronts occluding, and really the low pressure system tends to lose its identity. We are expecting not dissimilar weather with an occluded front as we would with a warm front. There's going to be rain, there's going to be clouds. It's maybe just not quite so textbook, but we are certainly expecting some weather to come with that occluded front before the low pressure system starts to disperse or dissolve. We can get some more information from our synoptic chart as well. So it's some really quite accurate information. It's not just big picture stuff. So if we look into our geostrophic scale, if we want to look at the wind speed and we want more accurate than just it's a little bit more windy when the isobars are closer together than they are if they're spaced out. So if we have a look at some of the numbers we need to gather, we would get our dividers out, we would measure the distance between the isobars that we're interested in, we would have a look at the numbers dotted about our synoptic chart. So in this particular one, relatively close to the middle or just left of centre, you might be able to see the number 50. So that's our latitude line, and where I am right now is 55 degrees. So between, almost halfway between that 50 and the 60 degrees latitude. That's going to be important to us in a minute. And we're also looking at the pressure gradient between the isobars. So how many millibars or hectopascals the pressure drops or rises between each of the isobars. So if you can see there, it's 1016, and then you know, at the top of the screen we've got, to the left of the 1016, we've got 1012, then 1008, then 1004. So we know that the different pressure is 4 millibars per isobar. We need all of that information to then take it to the next stage, and that's the geostrophic scale. So we take our dividers, we've measured the isobars at the 55 degrees latitude, and we can see there using this scale that we're about 20 knots of wind. Now that's the geostrophic scale. So actually to get the surface wind scale, we could not go far wrong by taking about 2/3 of that actual wind strength. Okay, so moving on to you know, other parts of the synoptic chart that we could expect to see strong winds. It's not just where the isobars are close together, but if you can remember back to those low pressure and high pressure systems spinning a few slides back, you'll remember that they were going in different directions. So actually where they meet, we can get quite an acceleration of wind. We refer to that as the squeeze zone, where the directions of wind converge and increase where the high pressure and the low pressure meet. And you can see that quite well using Windy TY's animation there. So that's another area to look out for. And I guess another textbook area to expect to see strong winds would just be in and around those cumulonimbus, where you get the squally showers. You tend to get quite windy experiences in and around those areas too. So you can just have a wee look and see where you might expect to see the strong winds round about here. If you can make out where Iceland is, I think that's probably somewhere we're expecting quite a lot of wind, partly because of squeeze zones, but also to do with just how close those isobars are together. So I'm pretty sure it was windy over that period in that neck of the woods. Okay, moving on to temperature then. So let's very quickly look at the big picture with regards to temperature. On the left, we've got something that's referred to as the Hadley cells. I remember getting taught about this many years ago and getting slightly confused by the whole affair. But really, if you just think about the prevailing winds you expect at the various different sections of the world, the northeast trade winds being one of the more famous, and if you have a look there, you can see how those are created. Now, where I am, where maybe some of you are in the UK, where it probably are prevailing wind directions more southwesterly. Not always, there's lots of factors, but this left diagram shows us how our prevailing conditions all come about. If we move to the right hand side of the screen, this is the birth of a low pressure system where warm air and cold air come in contact with each other, and there's always a bit of friction when that happens, and we call this cyclogenesis, and it's an area where the low pressure starts to form. So you can see how integral temperature and the different temperatures have an effect on the big picture weather, but we're now going to look at some more local effects of what the temperature actually does to us. We're going to break that down into three areas: sea breeze, katabatic winds, and poor visibility or fog. So starting with sea breeze, we generally experience this, or certainly it's more obvious in warmer climes. So in the Mediterranean, the Caribbean, these lovely warm places to go sailing, you can almost set your watch by it. In some places you're going up 2 o'clock, that'll be the wind starting to blow from the west or the east or wherever it might be. And that's all just generated by the sun warming up the land. The land changes temperature much quicker than the sea does. The sea takes many weeks and months to change, but the land will change fairly quickly over a period of minutes and hours. And throughout the day, as the land warms up, the area of air over the land rises, just like anything warm does, a bit like a hot air balloon. It will rise up into the sky, and if you're lucky and you have a wee gentle offshore breeze in the equation, that warm air will be blown out to sea, and very quickly you'll experience a sea breeze starting to happen. If we can have a look at that in my back garden, really. So I stuck the kettle on the other morning and witnessed a perfect wee sea breeze. So as you can see, the warm air is rising. It's almost forming a cloud as it does. But I was lucky enough to have a gentle offshore or out of house breeze, and that took the warm air out. And into the garden or out to sea, if you like. Now you're going to have to take my word for it, but I also felt, believe it or not, a little cold breeze in round about my ankles because I was wearing shorts that day. So I was getting that whole circular effect caused very similarly to the land heating up, but in this case it was the kettle heating up, but a similar effect there. So sea breeze, very, very common. Land breeze happens in similar way, but at night time, it tends not to be quite as strong or powerful in its effects, but it certainly can present itself. And I don't want to mislead, because a land breeze at night can also be fairly strong. Generally speaking, a sea breeze about a force 3 or about a force 4 can stretch up to 5, sometimes a bit more, but generally a little bit less when we talk about land breezes at night. A question I'm often asked is, how far out to sea might I experience the sea breeze or the land breeze? Well, I've had a good look to see what the Google suggests, and it suggests anything up to 20 nautical miles offshore, or in fact inshore. You can be well inshore and experiencing the effects of it. But it really is how long is a piece of string kind of question. It depends on how quickly the land heated up, how big is that land mass, how cold the water is, etc., etc. So there's lots of factors that would change that. But if you wanted, you could suggest that probably up to 20 nautical miles is about as far as you're likely to experience it. Okay. If we move on to something that's exceptionally similar, anabatic and katabatic winds, created almost exactly the same way as sea breezes and land breezes. This time, however, we're adding gravity into the equation. So katabatic winds are always the ones that concern me the most, partly because they are certainly more ferocious than your average sea or land breeze or anabatic wind, but also the fact that they happen at night time and generally after a nice calm period when you've been anchored in a lovely bay and you've just gone to bed, and all of a sudden it's not a very good anchorage to be in. So the fact that the air is cooling at night time over the land, and in particular up the snowy, icy mountains, it becomes cold and dense, and that dense, heavy air mass with the effects of gravity rumbles and tumbles down the hill and can come screaming out to sea and sound a little bit like an out of control train passing the boat. So that can be quite disturbing if you've gone to bed in a nice calm environment and then throughout the night it just becomes a little bit wild and unruly. So there's an area not far from me actually that I've been in many times that you can definitely be forgiven for falling into this exact same trap. So, pulling into Loch Ranza at the north end of Arran, for those who don't know it, it's an island in the Clyde. It's quite steep-sided and decent-sized hills and mountains near the north of the island. But you would be expecting on a nice sunny, clear day, possibly with a bit of high pressure kicking about, that Loch Ranza with a gentle southerly might be a really good place. In fact, even with a strong southerly, you would expect it, looking at that, be a really good place to go and anchor for the night. Now, if you look more closely at the land, you can see how close those the contour lines are, and albeit not towering mountains, they are significant enough that they can have that katabatic effect where the air mass at the top of the hills round about the north of Arran cools down throughout the night and tumble down and seem to gather some speed as they whistle into Loch Ranza, making the anchorage maybe not as comfortable as you would have wished. So that's somewhere that I'm just that bit more aware, because you've got a reasonably decent sail for several miles to get from there to somewhere that might present a bit more comfortable sleeping. So I've had to get up in the middle of the night there and deal with an anchor that's dragging, and then decide, oh sod it, I'm heading off to the Kyles of Butte or up to Tarbet and get there a few hours later, reminding myself not to take for granted the katabatic winds that can present themselves even when the mountains aren't massive. So moving on from that, another effect that temperature has is an effect on the visibility. And there's many ways that it can do that, but generally speaking, they all have something in common, and that's temperature. If we can come back then to the area I was talking about earlier, and that's my kind of local area, so I can talk with a reasonable amount of experience and confidence about what happens round about here. You can see the Mull of Kintyre on the left and Arran there, and probably the most famous mist or fog in the world, thanks to Paul McCartney. So I'm sure everyone who's sailed around the Mull of Kintyre can't do it without singing this song, so we'll just get it out of our systems, folk, and listen to the man who's better at singing it than me. Great, beautifully done by Paul McCartney there. So he's talking about the mist rolling in from the sea, and I guess he must have seen that happen for it to inspire him to put those lyrics into the song about the Mull of Kintyre, where I believe he has an affinity with and has visited many times over the years. So actually, the mist rolling in from the sea hasn't happened to me a huge amount in the area. It has happened, don't get me wrong, it's definitely happened, but I've actually seen more mist rolling out from the land out to sea. But we'll talk about those in a little bit more detail in a minute. I guess a bit of an in-house joke here, Scotch mist doesn't even exist. That is actually what the phrase means in Scottish slang. So yeah, if I've lost something, my wife will pick it up and go, so what do you think this is? Scotch mist. So it is referring to something that doesn't exist, but actually there is a weather phenomenon that's referred to as Scotch mist, but it's not really referring to fog. It's referring to a fine drizzly rain, or indeed even better than that, it refers to a cocktail. So a nice wee simple cocktail: whiskey, a few bits of ice, a little bit of lemon zest, and I've had many opportunities to try this out in various different ways. Stick a glass in the freezer as one, and then bring it out, and it all gets misted up. Then you pour the whiskey in, and you see the mist disappear from the glass. But this particular one's got a little bit of cheating involved, using a bit of dry ice. It's really good effect, and it definitely helps to show the mist there. I digress a little, however. There is a key point here, and it's all about the temperature and how the changing of temperature is the important bit. So maybe if we can all do an experiment now and take your glasses, if you're wearing glasses, or maybe just your phone out your pocket if you're not using it to watch the webinar, and breathe on it as if you were going to clean the glass. I would expect all of you to experience a kind of mist, a sheen of water on the screen. That's just that same process in a really simple and easy way to get our students or our instructor candidates or whoever just to really get the basics of the warm, moist air coming in contact with something cold. That's pretty much how all fog is created. If the warm, moist air reaches its dew point as it cools, it becomes fog, mist, whatever. Okay, advection fog. So this is probably one that's very important for us seafarers, and quite often actually referred to as sea fog. Generally, it happens around about the end of the winter, start of the spring, because the sea temperature is at its coldest, really, and the warm, moist air that's coming across the Atlantic, so a southwesterly tropical maritime breeze, travelling over a cold sea, and therefore reaching its dew point, and hey presto, we have some fog. It's unlikely that that's going to change much throughout the day unless we have a change in wind direction or wind strength. It's not going to burn off like some fogs might. It's going to stay there. If the wind accelerates and becomes much stronger, you might actually see it in more layers of banks of cloud rather than a thick fog. And of course, if the wind changes direction, then it may no longer be bringing that warm, moist air in. For example, something like a continental breeze coming from the east, it's likely to be bringing a dry air, and it may even be a different temperature, and we no longer have the ingredients to make the fog. Radiation fog, more likely towards the end of autumn and into the start of the winter. But what we're looking for here to make the ingredients all kind of work for us is a clear sky, so that the land that has a warm, moist air over it, the land cools really quickly and in relative terms becomes much colder, and therefore allows that warm, moist air to reach its dew point, creating the radiation fog. That's not a big problem for people out at sea, unless, of course, what can happen is there's a gentle breeze that just drifts that fog out to sea. Very common in estuaries, and really quite common in the Clyde, actually, where I am. I can be driving through really thick fog, reach the coast down in Largs somewhere, and it's beautiful, clear blue skies in Largs, but look up the Clyde to the north and to the estuary, and you can see a big bank of fog holding in there. That might well burn off fairly quickly as soon as the temperature goes up. The fog is likely to disappear, and of course, if there is strong winds, that would mix up the ingredients and change the dynamics, and likely clear the fog away. So, land effect. Moving on to how the land can have quite a substantial effect on our weather. First of all, really simple: lee shores, windward shores, nice and simple. I'm sure we're all very familiar with it, but we probably don't give it the same respect as we maybe used to, or seafarers used to, when there wasn't maybe reliable engines on boats or sailing craft that could sail pretty close to the wind to get away and beat away from these lee shores. But it's definitely worthwhile being fully aware of them, and whether that is because you want to avoid ending up on a lee shore and having that catastrophic, horrible, heart and mouth feeling of the boat drifting towards the rocks, or if it's just so that you can choose a nice suitable anchorage, or even just get a little bit of respite from the heavy conditions, choosing to go to the other side of a group of islands as you sail along to get some flat water and make a cup of tea, or go to the heads in comfort. But either way, we shouldn't detract from the importance of thinking about where is that lee shore, where is that windward shore, where am I positioning myself. Time for another question now, but just before we do, a reminder on wind arrows. So we've got the wind arrow on the left-hand side there, and a description of how to work out the wind speed. So for each half of a feather, we are talking 5 knots, and a full feather is 10 knots. So we've got 15 knots of wind there on that beautiful arrow on the left, and my slightly more shabby but similar arrow on the chart. We have 15 knots blowing into the Kilbrannan Sound between 2 bodies of land, and we want to choose where to position our boat. So we are travelling north with the wind behind us, so if you like, a nice run, and we want to get the maximum wind so we can go up the Kilbrannan Sound as quickly as we possibly can. So the question is, where do you position yourself? Is it to the left, is it in the centre, or is it to the right? Where do you think you're going to find the strongest wind? If I can just add a little bit more information in now, the words convergence and divergence, and the fact that when wind has friction placed upon it, it backs in the northern hemisphere. Therefore, with more friction over the land than there would be over the sea for the wind, it backs further, maybe as much as 30 degrees sometimes. So if you put that into the equation, does that change your answer, or does that not change your answer if you feel confident to stand by your first guess there. So really what we are looking at is the right hand side is where we're going to have an acceleration of wind, because there's wind bending from the land onto the sea, whereas on the Mull of Kintyre side, on the left hand side, the backing effect that is created by the land will bend the wind away from the sea, so it won't converge, it will diverge. So strongest wind on the right, for those who have got that correct. Well done. Using a similar scenario here, so thinking about how the wind is affected over the sea and how it's affected over the land, and by the backing effect, do we think on our port tack, as this lovely gaff schooner is, heading towards the bottom of Arran, are we expecting a lift or to be headed as we get closer to the land? So we are in fact expecting a lift, aren't we? As we get closer, we should be able to point closer to our destination as we get a lift from the backed wind. Good. Okay. On to terminology now. We could spend an awful long time on this, which I don't have the privilege of, and I also don't really think it would be of much benefit to anyone for me to just spout out lots of terminology. What we're going to do though is just put up a few scenarios that may seem to your average landlubber as fairly vague terms when we're talking about weather, but actually they're all very specific. They're not vague at all. They do mean something. So gentle breeze, what does that mean? We have a Beaufort wind scale of a force 3. And that, even more specifically to us, is 7 to 10 knots of wind. There's various ways to try and remember the Beaufort scale. Is it just parrot fashion? A force 1's 1 to 3, a force 2's 4 to 6, a force 3's 7 to 10, so on and so forth? Or can you come up with ways that make it a little bit easier to remember? One of the first ones that I was able to hold the information in my brain was a force 8. So 34 to 40 knots. So the 34, I'm adding that 4 to the 4 of 40, and that gives me 8. Therefore, it's a gale force 8. That might not work for you. It certainly worked for me, but using anything at all to try and get that in there. Still expected to know these terms for Yachtmaster, but it's a language that we all speak, so it would be good for us to be using that as accurately as we can from as early in our students' kind of experiences as possible, just so they are using it correctly. Moving through the rest of them then, I'm not going to waste too much time, but soon we've got 6 to 12 hours. Good visibility refers to more than 5 miles of visibility. Rough seas, 2.5 to 4 meters of wave height, and pressure system moving rapidly, 35 to 45 knots, which might help you position yourself or just decide what you're going to do next if you have an idea as to how quickly that low pressure system is tracking across the Atlantic. There is lots more. I've got a handout that I'm going to make available so that if anybody wants to borrow steel, use in the future, it's going to be made available to anyone listening into this webinar. Passage planning, probably the most important bit for me here, and what I've chosen to do in this instance is break it down as like a real passage plan that we have to do. Looking at SOLAS 5, we are advised to use APEM as our format, so appraisal for passage planning in general is just looking at the big picture. Planning, we're getting a bit more specific. Execute, obviously we're going to get ready to do this passage, and then monitor how is this going en route. I don't think you can go far wrong if you use this same format for thinking about weather. So appraisal, what is happening, big picture stuff all over the area that you're going to be in. having a look at a synoptic chart. Is it going to be wet? Is it going to be dry? Is it going to be windy? Is it going to be light airs? What are we going to experience, do we think? Plans, so we're now specifically thinking, where are we going to position ourselves, which side of that island, what time is best to be out on the water, is it the morning, is it the afternoon, all of that stuff becoming a bit more specific now. What kind of boats are we going to use? Are we going to reef them? Is it a motor boat? What angle to the waves are we going to be most comfortable in, etc., etc. Execute, so we're now getting ready, we're just getting on the boat, we're standing on the boat, we're looking about ourselves, making sure that actually this plan is going to work as we execute it, and that there isn't some fundamental difference to what we were expecting, and equally monitoring it throughout the course of the day, or longer if it is. So we're looking at, not forgetting the weather eye, our own sailor's brain that can really stand us in good stead. If we see a big, large cumulus cloud coming towards us over an island, then it might be a good time to hit the beach and watch this squally shower pass, hailstones included, while having a nice hot chocolate in the comfort of the classroom, or not. If we're deliberately wanting to up the ante and make the conditions a bit more challenging for our advanced students. But the monitoring, let's not forget that we have to keep a weather eye at all times when we're at sea, but I'm sure you all do that. While doing passage planning, in the weather sense, I'm looking at as many different sources as possible. As I said earlier, the synoptic chart's probably one of the first things I'll go to, but I'm also looking at the TV in the morning, if I'm having my breakfast before leaving. If I'm in the car, I'm listening to the radio, and just picking up as much information as I can. I'm looking at the inshore waters forecasts, I'm maybe looking at grid files, I'm definitely looking at some apps, just to see what as many different sources are suggesting I might experience throughout the period of the passage. If possible, we'd like to put that into relative terms for our own benefit, but also our crew or students. And what I mean by that is overlay that somehow onto a chart. So even just getting a chart out, or drawing that UK on the sand with the the simple outline, and drawing in some wind arrows and thinking about how is this going to affect me on this passage? What's it going to do to us? Not just there is a southwesterly and we're going sailing, but where are the lee shores? What is the sea state going to be like? Where is that warm sector that the visibility might not be very good? What point of sail might I find myself on? How is that going to have an effect on what my sail plan is? Am I beating to windward, looking for small sails, nicely shaped, or am I going to be looking for big billowing sails to head off downwind? What is that sail plan? And after all of that, we have a fighting chance of knowing how fast we're going to be travelling, what kind of speeds we expect, and also what our ETA is based on. We might not be able to point directly where we want to go. We might be beating to windward. We might be in a motorboat and deliberately not going beam onto the wind, or waves, I should say. So making the passages successful as possible and as comfortable as possible. Port entries, one that people tend to forget when I'm doing yacht master exams and I'm asking them about where might you go if things aren't going to plan. Have a think about choosing appropriate places that you don't end up trying to get into a harbour that's got breaking waves at the entrance. In fact, might even have closed its storm gates and you're not allowed in. So please look at where are you choosing to end up, and try and avoid those lee shores where at all possible. Great, I really hope that this has been of some use to you all, and that you've got some benefit from it. I hope to see you out on the water and using the weather to your advantage to run really dynamic and engaging sessions for your students that are creating a good learning environment for them to benefit from your knowledge. And in the meantime, I bid you all a sailor's adieu and wish you fair winds.